Good morning and welcome to the first day here at IPC Apex Expo. It's Tuesday, the 24th of January, and I'm joined here by Keith Bryant and, of course, my good friend Mike Conrad from Reliability Matters. So welcome, gentlemen. Nice to see you this morning.
Thank you. Good to be here.
Yeah.
Yep.
So we've got in fact, the first thing I'm going to say is coming in this morning, I saw this lovely sign said, welcome to the San Diego Convention Center, the home where great events come to happen. And I thought, well, you know, some of the technologies that we've got on the floor here happen to, make a lot of these life-changing technologies happen. So it's quite an appropriate place to be holding. They
probably didn't mean it quite so literally, but certainly you're right. Everything that affects life, everything that manages your life and protects your life and makes it better and keeps you healthier is made here. It's made by the people who are here.
Absolutely, yeah.
Yep, electronics is a huge part of just about everything in our world.
Yeah, that's true, that's true. Now, we've got a huge program for you this week. In fact, we're going to bring it up on the screen to just show you. We've got a couple of panel discussions this morning on planning your digitization and automation roadmap, and following that we'll have one on EV, which is a pretty hot topic around the show floor here. And following up later this morning we have Mike Conrad with his Reliability Matters. And who's your guest on Reliability Matters this morning?
Today, my guest will be Eric Camden. He's a lead investigator for Foresight, which is an analytical laboratory. Okay. So basically, if you don't do it right, you end up calling him. And he comes in and tells you where all the sins of the process were and gives you a big slap and a bill, and you don't do it again. So he has got a lot of stories. I call him a crime scene investigator. He's like CSI. He figures out where the bodies are and how they got there and who murdered them from a process standpoint.
Right, that's interesting.
Always
similar
got great
to what
stories.
you do, Keith, because I mean you've just come back from Asia where you've been doing some troubleshooting as well.
Yeah, mine's more, let's say, direct process line improvement based than the sort of in-depth forensic stuff that they do at Foresight. But yeah, that's all down to trying to make the yields improve and stop any failures in the field and all the other stuff. So yeah.
Okay. So I mean the industry just come through COVID. We've had supply chain issues, and we've still got a European war going on. But there's some people talking a bit about a global recession on the horizon. We're seeing some layoffs happening on some of the larger consumer-led companies. What sort of vibe are you getting out there from the industry? Let's start with you, Mike.
You know, I started my business 31 years ago in this industry. So we've been through many recessions, pandemics, add terrorist attacks, but we've been through all the cycles, ebbs and flows, and the causes of the ebbs and flows. This is different. This doesn't feel like a recession in the way it felt on prior recessions. Right. It doesn't feel anything like 2008, which hopefully nothing will ever feel like 2008. Right. It didn't feel like earlier recessions. I think what is either giving us a false sense of security or security, I'm not sure, time will tell, is the fact that electronics are exploding with IoT, with cars, EVs, electrification of cars, all that. And that's, even though the economic indicators seem to clearly point more and more that a recession is coming, we seem to be in our little bubble. Right. And I'm hoping the bubble won't burst. Time will tell. But it just doesn't feel classic to me. So I'm of the belief that I'm willing to concede that there could be a recession coming, and I'm thinking it will be milder. But I'm not an economist. Yeah. I'm a permanent optimist. So
some people are calling it a recession, meaning that it's the rich companies like the Apples, the Amazons, the Googles that are going to suffer in this correction, as it were.
Yeah.
And it's not going to really affect the wider electronics industry, which, as you say, there's an awful lot of new products coming through. I mean, it's exploding exponentially in all sorts of different fields.
No, I totally agree. I think anything that has been valued, that's a balloon value, things that are companies that don't actually build things but are worth money,
right?
They're going to get adjusted. Our industry, we build things. We are a materials company. We build product, and we get money for the products we build. And I think that will, I don't think there's a balloon in our industry.
Right.
I think we'll be okay.
And Keith, you think it's a correction, basically?
Yeah, I think it's a correction. Obviously, when COVID hit, all the automotive companies shut down. They cancelled all their orders. Then suddenly there was a boom in everybody working from home. So people were buying new laptops, Wi-Fi, consumer stuff, and I think that created almost a false consumer bubble, which we've now come to the end of. And I think that's what's causing the problems. It tends to be in the consumer stuff.
Right.
You know, what I'm seeing in medical, in aerospace, automotive, and all the, let's say, the higher end technologies seem to be pretty much still carrying on the way they were. I'm doing a presentation at PanPac next week using a lot of stuff from Custer Consulting.
Yeah.
And if you look at what's happening to the higher end of the semiconductor market, it's still just gently carrying on like this. It hasn't blipped, it hasn't anything. But if you look at stuff like above 12 nanometers, which is, let's say, the more consumable stuff, then that's running pretty flat. Right. So I think, yeah, there is going to be an adjustment, but even with the inflation that we're seeing at the moment, I don't think electronics is going to see a recession.
Great. Okay. Well, thank you for your insight, both of you, and thank you for coming in and joining us for the kickoff of the show today. We're going to be seeing you in one of the panels tomorrow and also for the wrap-up on day 3. So we'll look forward to that. And coming up after the break, we're going to be talking to Mark Waterman from ECD, who's got a brand new product to show us.
Koh Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionize the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Koh Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
And welcome back. I'm delighted to be joined now by Mark Waterman from ECD. Nice to see you, Mark.
Thank you, Trevor. Nice to be here.
Yeah.
It's an exciting show so far.
It is, isn't it? So we'll just get started, but you're here to tell us about a brand new profiler technology you've got. It's the Mole EV6, which is the industry's first traveling profiler with touchscreen capability. So let's have a look at it. Can you show us on the camera there? There you go. Okay, excellent.
Yeah, so it is the first traveling profiler with a capacitive touch display. It allows the user to be able to get live data from the unit, to be able to do analysis, and to get really instant feedback. So there's not a need to connect it to a computer to do your thermal analysis. So it's the ultimate in pass-fail right at your fingertips.
Right.
So we think it's going to be a time saver, make it easier to use. It will unshackle the users from their IT department.
Yeah.
So all kinds of exciting things. And it's kind of the expectation now with the new generation that
Everything has to be data-driven and traceable and everything else.
and instantaneous, right?
Yeah.
They expect to have a touch screen and have a display that tells them what to do, and they don't have to read the manual to figure out how to use it. So
I think we've got a small video clip of the EV6. So if we bring that up now, maybe you can talk us through it. Works.
No, absolutely. So it's got the same form factor as our older generation moles, so it's backwards compatible with our Rider products. Again, the interactive capacitive touch display allows you to do configuration, setup, to select your parameters. It has up to 7 different KPI templates that it can evaluate the profile against, and it'll give you a live display of the profile itself and the pass-fail data table that'll give you live information or real-time instant feedback on the profile. So again, you don't need the software to do the analytics or the data analysis. It's done for you here in an instantaneous form. If you need deeper analysis or SBC, you can download it to our software suite and use that for the deeper analytics.
Right. I see in that last little clip there, you were pressing the button for SAC 305. Do you dial in the type of alloy you're using?
Yeah, exactly. So you can make a custom data template based on the requirements of the solder paste. It'll hold up to 7 different templates, and they can have a multiple calculations based on what you're doing. So if you're doing underfill and curing, you can have a cure template. You can have multiple solder paste in memory, so to speak, and then apply them and look at the data with those lenses based on what application you're doing.
Right.
And if you're sharing this between lines, like I say, you can change the configuration from reflow to wave solder, hand it off without having to interface with a computer.
So that's interesting. It makes it very versatile then.
Absolutely, yeah.
And of course, making things easy for operators these days is critically important. So having a good GUI interface is makes things easier.
No, absolutely, and that's it. Not only makes it easier for the operator, makes it easier for the company that has to provide training, makes it easier on us because we don't have to provide the training.
Right.
So it's a win-win-win, and that's what we're here for, is to make innovative products that are easier to use and save time and make it easier for everyone.
Okay, great. So when will they be available?
We're taking orders at the show. First ship is going to be March 1st.
Okay. So it's almost just around the corner. So
it's available right now. We've got them in stock.
We've got them in stock. No issues with supply chain problems or anything.
There's always issues, but we've inventoried up to take care of that.
Great. Okay. Well, I want to thank you for coming in and telling us about it today, and I wish you the best of luck with the new Mole EV6.
No problem, Trevor. Always a pleasure. Thank you.
Thank you very much. Okay. Coming up after the break, we're going to be talking to Brooks Automation, who've got a new Precise Flex cobot that they're going to show us.
The Arch FX manufacturing platform, processing over 1 trillion data points each month, bringing value to every level of your organization. That's manufacturing insights for tomorrow.
At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important. Expand your inspection capabilities. Inspect in 5 directions using top and 4-angled cameras simultaneously. Find defects that a single camera can't detect, such as OCR and QFN solder bridge. Best in class performance 18 megapixel sensor.
And welcome back. I'm joined now by Tim Rossett from Brooks Automation. Nice to see you, Tim.
Hi, Trevor. Good to be here. Yeah, thank you.
Yeah. So you're one of these new guys that's come into our industry from the robotics field. Tell us a little bit about what kind of robotic configurations that you offer EMS companies.
Sure, yeah. So Brooks Automation is a lot of folks probably within the industry are familiar with Brooks Automation in that they're coming from the semiconductor side and the processing side. Okay. But we have a line of collaborative robots that was an acquisition a little over in 2021. Precise Automation. Okay. We brought that into Brooks, and then we're investing, growing that portfolio, and it's collaborative robots. So robots that are designed to work inherently side by side with people and enable people to do the things that they do best and allow the robots to do some of the more tedious and mundane things. And so the applications we're looking at are PCB, PCA handling, test, and packaging.
Okay. So you're the Brooks Automation that's actually doing the FOUPs and
yes.
robots for the semiconductor
exactly.
side.
That's the core business, and then the group I'm in is the Precise Flex collaborative robots. Yep.
So talking about that acquisition you made with Precise Flex, I think we've got a photograph of one of the cobots that you are actually showing here today.
Right.
I've just brought it up on the screen. Maybe you can tell us a little bit about this system and how it works.
Yeah, so again, Precise Automation came out of life sciences and lab automation, so working closely with the lab technicians and working with a lot of expensive and sometimes delicate equipment. Mm-hmm. So one of the design criteria was to ensure that if someone bumped the robot or if the robot bumped a machine, and that it doesn't do any damage, doesn't harm people, number one, but it doesn't do any damage to equipment, and so we've carried that forward. We've enhanced the designs, and we're really going after general industry, and to do a broad range of applications within manufacturing, and within the electronics industry. That's certainly an area that we see a strong need. That's sometimes similar to lab automation in that it's confined workspaces, working side by side with people, and we see a lot of similarities there.
Okay. So what sort of technologies do you use to stop the cobots from bumping into people? Is it LiDAR sensors or what are you using?
Our cobots, unlike a lot of the other traditional collaborative robots that are on the market, are inherently safe. So they some of the if you want to talk technology, they have our robots are moved on a horizontal plane for the major axis, so they're not moving against gravity, and as a result, we're able to have very low gear ratios and very low reflected inertia. So they'll very low moving mass, so that if it does happen to bump you, we're able to stop. We have some advanced controls algorithms that we're able to stop very quickly, so we can move at a higher speed and be able to stop quite fast.
Really? Yep. That's interesting. And presumably they come in all sorts of different configurations. What's the maximum axis that you can offer in your? So
we have our standard is 4-axis, and a lot of in the semiconductor and the electronics industry is planar, is flat to flat applications. But we also have 6-axis versions as well. 6 degrees of freedom that gives you the full pitch and articulation. Yep.
Okay. So one of the things, of course, about these systems is how easy is the software system to teach.
Right.
How simple is it to teach your robot?
Yeah, we have. That's one of the nice things about collaborative robots, and that has changed the paradigm around people's thinking around teaching and deploying. People don't want to program robots. There's some sophisticated applications that you need to program, and there's no getting around it. But there's a lot of basic applications that we have a web interface. Just pull up your tablet, connect to the robot, and configure the application rather than doing programming. So they're quite easy to deploy.
Right.
Again, I want to preface that by it depends on the application, right? It depends. But for a lot of the basic applications, it's quite easy.
Okay. Now, in our industry, there's a lot of different applications where AI is starting to come into play. Do you foresee that's going to happen in your end, in the robotics side?
Yeah, I think some of the advances that we're seeing, I think in large part the advances in software and AI help with analyzing data so that it's actionable and you can make decisions. The manipulators, the robot arms themselves, frankly, are for the most part a commodity. I maybe shouldn't say that because I'm in the robotics business, but manipulation is a commodity. So the robots will do whatever you command them to do, whatever you tell them to do, and the real advances are making those decisions and enabling effectively knowing what type of commands and also how to maybe optimize over time. Is now there are certainly some advances that are happening there to be able to optimize some of the processes and learn over time.
Right. Okay. Well, it's an exciting space, and it's certainly changing a lot of the factory floors across the country. Are you seeing quite an uptake from American manufacturers to want to automate?
We're seeing a fair amount of demand for reshoring and nearshoring. We're seeing not only in the U.S. But Mexico as well. A lot of activity in Mexico and a lot of manufacturing that's maybe lower volume, higher mix that their companies are really wanting to bring back. Either.
One of the interesting dynamics I've seen with companies that are reshoring or bringing it down to Mexico is that they're using best-in-class equipment, whereas maybe in Asia they were using cheaper stuff. They're using best-in-class over here. Are they also using that opportunity though to automate more of their processes?
Absolutely. I think the advances in robotics, the costs have come down while the technology and the systems have gotten better and more reliable. Our robots, for example, have a design life of 40,000 or 100,000 hours, depending upon the model that you choose. So that's quite long, as you say. Some of the other competitors in different markets maybe are lower cost and they don't have the reliability. So reliability is number one. Right. Flexibility and agility in manufacturing and the process is number two as well. But we're seeing a lot of companies automating things that maybe they weren't thinking about 5 years ago or 3 years ago, and then that kind of leads us to conversation around labor shortage, which is
another issue,
a challenge that everyone's struggling with.
Yeah. So, I mean, what would be the average ROI on one of these systems? I know it's difficult to pin that tail to the donkey because it depends on how many your use case. It depends on lots of different factors. But I mean, in your experience, what would be the average ROI?
Yeah, it does vary substantially, and it depends upon the complexity. But companies that are running 2 shifts, 3 shifts can really get a compelling ROI. In many cases, it's a matter of weeks as opposed to months or years. Right. It used to be that the target was 18 months, 24 months plus to get an ROI, and we've seen that come down substantially. In some cases, it's under 12 months, and so it's quite an attractive ROI.
Right, interesting. Yeah. Great. Well, I wish you the best of luck with the Precise Flex cobot, and I want to thank you for coming in and sharing that with us today.
Thank you, Trevor. It's great to be here.
Okay, thank you. So that brings us to the end of Tech Talk Live here this morning at Apex. We're going to be coming back to you shortly with the first of our panel discussions. But in the meantime, we're going to be showing you after the break an interview I did with John Mitchell from IPC yesterday.
Koh Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, We revolutionized the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Koh Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
Welcome to IPC Apex 2023. My first interview every year is with John Mitchell, the president of IPC. I'm delighted to see that he has joined me again this year. And it's great to see you again, John.
Good to see you too, Trevor.
Okay, so this is our last year here in San Diego.
For a couple of years, yep.
For a couple of years. So tell us, first of all, what we could expect to see this week with the show and how it's changed, because this is our first real post-COVID year,
right.
And also the supply chains are starting to work through, so things are getting a bit smoother in that respect.
Yeah, we're very excited about this year's show. It's really, last year was great to be back, but we were fighting with Omicron virus at that time. And this year, like for example, on the professional development and the training side, there was a great program developed by the committee, and we're at levels we've never seen before.
Yeah, I've seen some pictures of that actually. Your classrooms are pretty full.
Even on Saturday, I think we had 175 people in just one of the standards committee meetings. So we're just excited to have the industry really coming back in force. And so when the industry comes together, great things happen.
Absolutely. So interesting, you're getting these standards meetings going again. Obviously it's at a time when the industry and the technology is changing quite a bit, and some of the skill sets that are coming into that. What are some of the things that you're doing on that front with the...
Yeah, so standards is core to IPC. It's core to the industry. It's so critically important. And while we hold meetings all year round, there's really just a couple times a year that we hold face-to-face meetings, and this is probably the largest of those. So getting together, and it just helps move the standards forward. And as you mentioned, there's a lot of new stuff going on right now. We have, the same general trend of getting smaller and smaller has now kind of, we're starting to leapfrog. We've got a couple of standards out there that are working in the advanced packaging space, in terms of SIPs or substrates. We have the whole sustainability realm that's coming in and going to have more and more impact. So while standards may have been, along the whole path for the past 60 plus years, we're going to be continually having to revise and add to that standard lexicon as we go forward. So, yeah.
Right. Well, I mean, that moves into other areas. Some of these things you've been talking about. I mean, for example, skills, the skill set. I know you were doing some things with STEM programs and other things earlier, but I mean, with the automation that's coming into the industry, I mean, a lot of the production managers have really got to know how to handle data and interpret it and make use of it.
Yeah, in terms of skills, the whole world is changing so rapidly, as you mentioned. And so at every level, we have to, it needs to be part of a continual effort on behalf of the industry to keep the right skills up to date. Right. And so whether that's a production worker or, as you mentioned, the STEM thing, our STEM activities, this year we had to expand it to 2 days because we have over 500 high school students coming to check out the show, which is fantastic that we've got so many people we get to expose to the industry. And as you're trying to bring new people in, we have now IPC offers skills-based programs that can take you literally from working, you could be working at a bank. Right. And in 2 days, you could be productive on the line with these new training programs that the industry has helped develop that IPC has then, put the instructional design on top of. But also then for engineers. So engineers have new skills they're constantly needing to develop, and we have programs around that as well. So our job is challenging in that we have to listen to the industry about what is it you need next, and how quickly can we pull the industry experts together to help us understand what they need to know, and then deliver that back to them.
Right. But with the increasing amounts of data coming into the industry, is it going to be the production manager's job, or are you going to need a data expert, really?
Yes, depending on the size of your organization. So for smaller organizations, you're not going to be able to probably afford, I've got a specialized person just working on data analytics. So that's like a skill set that we would, in terms of upskilling the industry, that you're going to look to add into your production managers, your engineers, et cetera, so that more people know how to do that. When you remember when word processors first came out, there were just a few people that used that. Now everybody does it. Yeah. And so I think this is going to be the same with data analytics and some other key skills for the industry.
Yeah, yeah. Now you touched on the topic of advanced packaging there. Obviously with miniaturization happening increasingly, the gaps between the assembly and advanced packaging world and are converging.
Yeah, for sure. And so there's been a lot of excitement that has happened literally in many countries all over the world about the whole CHIPS Act and CHIPS Act-like things. People are like, we want to bring the semiconductor capabilities into our country because that's an enabling technology and they view it as part of the future. IPC has been spending a lot of time with our advocacy efforts globally, helping these governments understand that you can't just do the chip.
No.
You have to have the entire ecosystem fitting there. So, we've advocated for the inclusion of advanced packaging in the European CHIPS Act, and gratefully we were successful in helping that happen in the U.S. CHIPS Act getting passed as well. And it's really, depending on where you are in the size of company and what your business is, but this is really the evolution of printed circuit board and EMS. The future of printed circuit board is leading into substrate type technologies, and the future of PCB is moving into OSAT type of assembly. And so we felt it was very important for IPC to lead out in this. We've done it with studies, we've been engaged with government, and we've been engaging the industry in it as well.
Yeah, I think it's a great idea, and I think the thing with the CHIPS Act and also the European equivalent is that it's also it's also going into the sustainability because it's shortening the supply chains and making it a much more.
If done right, it should be.
It should be exactly if it's done right. But it's an ever-changing world, John, and it's fascinating to see it. So, what do you think is coming next for IPC in 2023?
So we have So in 2021, we announced ESG for electronics. A lot of the investment community was trying to make sure that ESG was part of the consideration in their businesses that they were going to invest in. The next step in that has been an initiative that we're announcing broadly is our sustainability for electronics. So it's a broader reaching. We're reaching out to industry leaders across the globe to help guide that effort. It is so broad. Sustainability you can attach just about anything to it. And so we're trying to figure out what are the right pieces of that we need to emphasize and solve for the industry. And we're looking forward to, we've already had several significant companies raise their hand and say, I'll be there, which is fantastic.
Good. Well, it's great to see that you're getting so much engagement from the industry.
We don't exist without that.
So, of course. But anyway, always great to catch up with you. I know you're a busy man and you've got a show ahead of you, so thanks for coming in and joining us today.
Always a pleasure. Thanks, Trevor.
Okay.
Koh Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionize the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Koh Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
the Arch FX manufacturing platform. Processing over 1 trillion data points each month. Bringing value to every level of your organization. That's manufacturing insights for tomorrow.
At Kaizen, we know it's the science that makes the difference. The right solutions happen.
Koh Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionized the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Koh Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.
Okay, and welcome to the first of our panel discussions here today, planning your digitization and automation roadmap. All EMS manufacturers need to developing a clear strategy and roadmap for their digital transformation journey. This panel will discuss how to invest in the right technologies and tools to support these goals and build a cross-functional team. I'm delighted to be joined by Jeff Peabody on the end from Critical Manufacturing, Michael Ford from Aegis Corporation, Peter Bollinger from ITAC GmbH, and Tim Burke from Arch Systems. So welcome, gentlemen. We're looking forward to a good and rigorous debate because we've got some pretty smart people on this panel today. So let's get started with, first of all, a breakdown on the digital roadmap. What technology areas does it encompass? Now, Tim, you actually were kind enough to give us a chart that we're going to look at now, which outlines some of the blocks that you believe are involved in that journey. Perhaps you can talk us through it.
Sure. So when we see, what's working across the industry in many different factors, many different scenarios, we see a couple commonalities. The first being that machine data is playing a central role in digitization, getting rich events out of machines, not just simple KPIs, but rich, nuanced detail of what's actually happening on a shop floor. Streaming that data into multiple systems, could be into the MES, could be into multiple other factory systems like an SPC system, a QMS, ERP systems, both inside and outside of the factories. A need to unify data between older equipment, maybe with PLCs, next to very smart advanced equipment at outputting files or complex traceability data, putting all of that together and then leveraging some more advanced cloud-based systems to do advanced analytics on top of it in parallel with the standard local shop floor control, advanced shop floor control, maybe some edge-based AI or machine learning. People always talk about this. And we see all of that sort of flowing together around this streaming event architecture, unifying data from machines and keeping that rich nuance so that the consumers decide what they need to take from that to power their applications.
Well, that's quite a comprehensive list there, of course. Peter, do you agree in general that's the way it should flow, or do you have any changes to what was described there?
Yeah, I think there's two things we need to consider, right? Of course, we need the data, right? And of course, we need to analyze it. When we need to get in the factories machine learning AI capabilities. The problem is today in the cloud, if you stream all the data up, it's very expensive, right? So you have to have a way to connect to the brain to the cloud, because every day Google, Amazon, they come up with new algorithms, new technology, and now you need to build a bridge between that knowledge and get it back on the factory floor. So for my opinion, what's missing on the chart a little bit is an edge device that is able to download the AI from the cloud in the manufacturing environment and run it there. Right. Because you will not be able to run it in the cloud. There's latency problems, there's performance problems, and so on and so on. So an edge device is absolutely needed to make it work in a factory.
How receptive are manufacturers coming to accept cloud-based technologies? I mean, for a while there, they didn't want to have anything going outside the factory. I mean, are they becoming a lot more open to this?
No, that's what I said. You need the edge, right? What we want to do, and manufacturing are still resistant to go completely in the cloud. As I said, cost is one, security is another one. Right. It may be change in 5 years from now, that's still a problem. On the other hand, we cannot afford to lose the knowledge that's there. So what we should do is we should train models, we should take the knowledge from there and train models in the cloud, but then take it back with pressing a button or something like that and immediately run it on an edge device and perform it. And that's the way to go, because then you're still disconnected from the cloud. You use the best of both worlds. So you can run it in the manufacturing, you're secure, no problem. But for the training part, you use everything that's available to us in the cloud. As I said, millions of people working every day to enhancing algorithms over there, and we need to build the bridge to it.
Yes, yes. Well, I know, Michael, that you're very hot on the security issues. I'm sure you probably agree with that.
Yeah, security is one of the main things that people should be aware of today. And I think there's a marked change from the user or customer perspective as to how to build that digital roadmap. Because in a few years ago, let's say, people would go to a solution provider with a list of boxes to tick, and that would be their potential return on investment that would help them decide what solution to use. Times have changed. We need to think about security of data. We need to think about interoperability, because there is no one solution provider that can provide everything. We have many vendors of machines on the shop floor. We will have many vendors of software solutions. So analytics, as Tim described, taking those into a cloud, taking them off-site, doing them on-site. There are pros and cons. There are different things that fit different people. So I think that rather than inundating people with technical jargon, the customer, the end user, needs to build what they think is important for them. Right. These are the business issues that I'd like to solve, not just today's problems, but I want to have that established for some time. Because their biggest cost going forward is going to be the cost of ownership, not the cost of purchase. Right. So therefore, they need to have that strategy with security built in, interoperability built in, and for some of the smaller customers, they really need to pay attention to the cost of machine connections.
Right, right. Jeff, I mean, I think it's a very important point about interoperability, because you go into a lot of factories and there's a completely different mix of equipment on the production lines, and sometimes companies buy different best-in-class products. Sometimes they do it through acquisition and they acquire different types of products. But it's important that you can connect to anything, both on the machine level, but also, of course, on other software platforms. Would you agree?
Yes, absolutely. Interoperability, and I think IPC has gone a long way to create standards to facilitate that. So that is absolutely critical. One of the points that I wanted to bring up, we we see a lot of companies, and this was a beautiful chart, by the way, that was brought up. But some people will see that and they're like, wow, that is complex. How do we approach that? And I like the wording of the question because digital transformation is a roadmap, right? It's a journey. It's not that you're going to get there immediately. And one thing that we, can happen is companies will get into this, what I call analysis paralysis, where it appears so big that they don't move forward. You've got the connectivity, you've got the cloud decisions, you've got security, latency, all those questions. But really, digital transformation, all companies have gone through it. If companies have moved some of their stuff to the cloud, that was a digital transformation. If they've implemented an ERP, that was part of a digital transformation. What we like to tell our customers, and we see a lot of people who don't necessarily do this, is at the beginning, map your process from beginning to end. And when I say beginning, I mean from taking the customer order to getting products back and returning those products or getting returns from customers. And then, like these gentlemen have said, identify that value stream, what solutions you want to plug into different pieces of that.
Okay.
I'd like to add one thing to this. I think we have a job to do. We're all software vendors, right? And the chart is complex, that's correct. Mm-hmm. But it's like I compared with a car now, right? In a car, you have an eco mode. Yes. So you can switch to the eco mode and you drive eco mode. The control behind it is complex. The car looks at RPM, the car looks at gearboxes, all kinds of stuff, does decisions for you and drive it. And I think our job is that we make this complex thing that's behind it simple for the end user, and the end user can just implement his use cases with simple tools. So our job is to make this picture behind the scenes, like in a car with the eco mode, and the customer just has the button and say, I want to drive now with AI, and I want to drive with machine learning, and he defines the process which he wants to choose, and then he drives it. And I think that's our job as software companies, to hide the complexity behind and make a simple solution for the customer to implement it, because none of our customers has the expertise to do this kind of problems right now, and
very true.
They are not finding the people right now. Right? If you go off today and say, oh, I want to have a data analyst or I want to have an expert on this topic, you pay a fortune, number one, and number two, you will not find it.
Well, that kind of brings me to my second question, which is what are the skills that are needed to achieve this digital transformation? I mean, is the production manager in the factory, is he got to be able to interpret this data and make decisions, or is it really going to be, they're going to have to start hiring data analysts to back this up?
So I wanted to reinforce and echo what was just said. I think at the end of the day, one of the opportunities in Industry 4.0 is trying to find off-the-shelf solutions for analytics that may be complex internally, but are simple and explainable to people on the factory floor in terms of what they benefit them. And so talking about what skills are needed, one is to build them, one is also to use them. We see a lot of need for factories to understand data and like what you can do with it, how it can power it, but how it's relevant to your job and your particular function. And so to the point of mapping your process end to end, there would be a different answer for, could data help you do receiving? Could it help you do control? Could it help you do quality? In what ways? And what are the examples specifically of not the technologies or the algorithms or any of that, but what do you see? How does it help you? How does it impact you? And then is that available to you? Could you actually choose to buy or build that if you wanted to? Or are you going to get stuck trying to implement it because you don't have the different skills needed to build it, but you do know how to use it?
Yeah, it's really tempting for companies to just want to grab the low-hanging fruit and say, oh, we have this problem, we want to address it with something. But the reason I think we're all mentioning, map your value stream, is because you've got to create this vision, right? You've got to have the whole vision, and then maybe you grab low-hanging fruit. But if you start by just grabbing that low-hanging fruit, you're going to end up with what they called silos of automation, some time ago. So.
Yeah, we've got to remember that customers are customers. They're not the technical experts that we are. But they do demand information. They want to know what's going on. And that is really to inspire confidence in the solutions that we all provide, because they know that this is going to make or break their operations. And some simple mistakes, some poor choices can lead to all kinds of problems happening in the future. So they need that level of confidence. To go in there and start explaining everything at a highly technical level, they kind of gain confidence and then they get confused. So it really is a matter of understanding the customer's need in terms of what are they really looking for as part of their business. Whether that is performance, some kind of connectivity, the cost, and the security aspect. And then really being able to meet that need and give them the assurance. This is not how it's going to work tomorrow, because that's a given. It should work when you first install it. But also this is how you're going to go in the next 2, 3, 5, 10 years. This is kind of the ecosystem or the structure in which that value is going to grow over time.
I think I want to add something to what the colleague said here. And I think I would start a little bit different, right? I would not say what expertise is needed. I would say, what do we have?
Right.
So what do we have in manufacturing? A lot of expertise on the process, a lot of knowledge about things that are going on. So now, again, our job is that we're building tools that enable these guys to get this knowledge inside a piece of software that does a job for them.
Yeah, so essentially what you've got to do is go and do a technology audit, first of all, of the customer to see what he's got, and then act as almost like a consultant to suggest this is the way that he could enhance that or optimize it.
I would even go a step further, right? Because the mix that we're having, right, in manufacturing, right, we have old, new, and so on, right? What we need to do is we have to deliver something that can adapt to it quickly, and that's our job in the installation. But then, like with the car, same analogy, we have a driver, and we tell the driver, you just press that one button. Don't worry about the rest, right? And that's our job, right? So we have to make sure that this technology, which is available, is so canned in a solution that they don't see it. And they just know, okay, I'm an expert on my process. I have a certain problem to fix, right? And then I know which button I have to press. And I don't need a special training on AI. I not need to know about machine learning, and definitely not to need to know about IoT technologies that are needed for that, because that's our job, right? But that's the way we need to drive it, right? So they have the knowledge, and we have to find a way to get that knowledge in the software, but in a very easy way, so they not need to have the experts. Otherwise, we will fail. The next thing I think that we should do is standardization of the algorithms and AI solutions, because we have an SMD process, right? And certain things are the same in all the factories. So now we have to look for algorithms and improvements in machine learning that everybody can use, right? And when we standardize that, the only thing we need to do is we deploy it and it runs, right? And that's the way to go.
I don't disagree. However, I think there are two different perspectives. One is to automate what we already know, what we already do, make it better, faster, stronger, put bionics into our manufacturing, that's fine. But I think we're also learning a lot. I mean, Tim's technology especially. You can start to analyze things and you learn. You learn about problems that you didn't know you had, solutions that you need to look into in a lot more detail. This is where the kind of sharing of data and ecosystem approach works, because things may appear to be symptoms, and if you spend too much effort to solve them, you end up losing the bigger picture of what is actually the cause. And the causes can sometimes be something so simple that people didn't even recognize it when they saw it. So as we move forward, I think our role as software providers is not just to focus on automating what is currently happening, but actually preparing manufacturing for the future and understanding all of the different ways that we can automate using software and achieve that Industry 4.0.
Right, okay. So let's boil it down to its simplest use case. How does a Tier 4 manufacturer with one line benefit from this?
Poor Tier 4 manufacturer. I would say there is a very easy solution. And Tim and I, for example, we work with the IPC CFX, and you mentioned IPC standards. We've had examples where people have been able to connect to CFX qualified machines, able to take the data, and a student, for example, making some kind of dashboard within, a couple of weeks. So they are not faced with the sticker shock of, first of all, starting with a solution from one of the big guys, and then thinking, okay, well, that's quite reasonable for the ROI, and then thinking, oh, how am I going to connect to all of these different machines that may need customization or middleware and that kind of stuff. So for a Tier 4, it's got to be almost free, and it's got to be something that shows them how to create value from data. because people don't read the brochures. They don't believe it until they see it for themselves. Right. So having an encouragement to take that first step, to create that value, to understand this is not a symptom, this is a symptom, this is not a problem, the problem lies somewhere else. That is how they go forward.
Free is a very interesting word, isn't it?
Yes, indeed.
So,
free, actually.
So anyway, Tim, I mean, your particular company does a lot of stuff with tier ones, where they're soaking up data from across the world, across multiple different platforms. How do tier 3s and tier 4 manufacturers benefit from the data intelligence that you would get from one of these big tier 1s?
Yeah, so it's a very good question. And I think the way I would answer would echo some of the things that have been said already, which is if the data is shared and embedded in solutions or models, as was said, or solutions to problems that are learned, for example, like you needed to look at, say, 500 lines to know, like, this is how you solve this problem. But once you know that, it's the same solution that you would put into a tier 4 or a tier 3 if you have 2 lines or 1 line. Now the question is that solution available to the tier 3s or the tier 4s to purchase or implement, or is it still locked up only with the tier 1s? And so I think one opportunity we have with more data sharing, with more ecosystem approaches, is the learnings that are done on the 500 lines, the 1,000 lines, like the giant tier 1s, get translated down to the tier 3s, tier 4s, not by people moving from company to company and bringing their best practice, that's one thing, but also by having standard solutions that this is what is used on every line in the tier 1. You can also use it on your line if you want. It will work the same, will solve the same problem for you, but it is finally available. It's not like it's only available with a giant implementation, a giant price tag, which needs 500 lines before it makes sense. You can get the same thing pre-built for your 1 or 2 lines, if that makes sense.
But I mean, are the tier 1s going to be happy with you giving up that information? Surely that's a USP for them, you would have thought.
So I think everyone has a perspective on this question.
Yeah, I think, as I said, there's 2 things, right? We have to distinguish, right? Of course, there's protection of intellectual property, right? And the tier 1s are eager to do that. On the other hand, we have also a job. Some of the things we can also come with standards, right? And then offer the standards to others, right? For example, we have a cooperation with a company that is willing to share the knowledge with others, right? And that's okay. So we do that, right? So we try it out in a factory, and then when we get something working, as he said, standardization is then the word, right? So we need to standardize it, and then they can benefit from the standards we have. Of course, we can do that, but as you said, there will be limits, right? Because not everything that the tier 1 are doing will be available to everybody, right? But a few things might be available to the others too. Sure.
And your comment was right on, right? These tier 1 companies are very protective of the IP, and they should be. One of the benefits I think that these tier 4 companies get is through buying a commercial product, they're actually getting a product that has know-how from a very broad spectrum of customers. So things that maybe they're not thinking of, but that somebody else has, and it's been put in standard product. But the question on tier 4 manufacturers is really an issue of skill, right? And typically what we see is the first one takes most of the resources, most of the thought, most of the effort, and then to duplicate that, gets substantially less expensive. So really that's what they're trying to overcome. But by buying a commercial product that has a lot of capability already implemented in it, they get the same benefit.
Yeah, I would go along with that and say their main problem is actually scale because they have so many operations with so many different types of machines, so many different people with so many ideas, experiences, history. They all start arguing with each other, and you end up where nobody is actually the real owner of the information. So when we come along with solutions, as Peter was saying, we need to bring that know-how in. We need to provide that kind of solution that is, turn it on and off it goes. So in that kind of level of customer, education is done in a slightly different way as we would do to a lower tier customer. But really being able to have the buy-in for people to understand that this is how we automate what we have, but this is how we use data to create further value. It can be an open-ended adventure doing that, and people will learn different things and start to align across the organization as time goes on. Because if you don't do that, the big organizations will fall out with each other. I've seen it happen, where one company says, we don't do it that way, you make a different product for a different market, we're not going to buy that system, we don't really respect it. But if you can provide a top layer, as with the analytics that is actually showing them day by day advantages and values, they begin to think, well, okay, maybe we want to go along with this, and maybe we'll align because we know it's bringing us benefit. So the politics involved are very, very strong, and once you get that together, it can be extremely valuable.
Yeah, I think there's a whole range of things, as you mentioned there. I mean, and even across the different geographies. For example, Tim, I mean, you're gathering information from factories that are in Asia, where the humidity and temperature is completely different in the factory, and everything behaves differently, and trying to match it up with products getting made here in the United States or in other parts of the world.
Yeah, so these are all correct statements. The large tier ones are also just a collection of many factories put together, possibly through acquisitions. There are many humans involved. Whenever there are humans involved, there are politics involved. And I would say as well, even the tier one, some of the ones that we work with, they are also looking for ideas. Okay, well, how should we do this new data thing? Like, what can actually help us? Sure, we can collect it, we could throw a bunch of money at it, but what is the ROI? What's the opportunity? And so one area we found a lot of success is providing expertise into that equation, not on how to run the factory. We do not know how to run your factory better than you do, but we do understand data, we understand how to analyze things, and we can talk the language with your experts, your people who actually understand your processes, and take the best of both worlds and say, okay, what do you really, if you were to solve this problem for real in your factory today, what would you do? And then try to translate that. Is there a standard approach we could build into software that works in a similar way using your expertise? And that together can help the tier one. And in the case where it makes sense to share, where it's not IP protected, it can also make sense to share more broadly and also then trickle down to the tier 2, tier 3, and tier 4 in ways that are now just standard off-the-shelf products, but could be very complicated, but as Wood said, simple to use.
I think I would drive it even one step further and say, okay, we need to look at manufacturing and say where is pain points and where can we save cost and improve performance, right? Number one. When we figure that out, we say, okay, where's an area where we should focus on, right, and help with our expertise and say, okay, this is a big area. For example, one area today is testing, right? It doesn't add anything to the process, right? If the product will all be good, we don't need testing at all, right? So that's maybe an area to focus on and say, okay, how can we reduce the number of testing, which at the end helps the customer to save cost and people, right? Well, and then our job is then, as he said, consulting and try to find solutions to reduce the effort of test inside manufacturing, right? And then they save cost, and then we have a problem solved that we can standardize and then maybe give to others. But clearly, right, a big company benefits more than a small one from that kind of stuff. Sure.
Right. But going back to your question of test there, Peter, I mean, test is very much the eyes and ears on the line. And the trend at the moment seems to be adding more test areas rather than less on the line. Because at the end of the day, the earlier you can catch the defect before you solder it to the board, then the more money you're going to save.
Right, but you have to look at it different, right? Right now we have a tester. So tester does in his station whatever. Data, right? What the tester doesn't do. The tester doesn't look at all the process data around. But let's look at the test, right? And that's, I think, what we need to change. So we need to look at all the data that are available to us from every process that we have in manufacturing, analyze the data, and then do predictions and say, okay, when we have this data there, and that data there, the sport will never fail in test, right? And that's the way to do it, right? So we have to go out of the silo and say, this is a tester, right? We have to go whole
look
process,
at the entire environment,
environment, and then do predictions. Right. And that's the whole idea of machine learning, right? Or artificial intelligence is to go in and say, let's look at all kinds of stuff which a human can't do in a short period of time, right? And let the computer look at all the data, make sense out of it, right? And then drive a decision for us.
Okay.
This is a really interesting area because I agree that testing is a complete waste of money because you never plan to make defects. So great, end of story. But it's not, because Testers used to be there to filter out defective products. They're not actually used for that anymore. They're there to gather the data for analysis, because you get more data from a product that passes than a product that fails. So that you can understand then what are the unique set of circumstances that's occurring on this product. Then that comes from context. So machine learning is maybe one machine learning by itself, getting operator feedback. Then you connect 2 or 3 machines together. There's a limit on how many machines you can connect. So then you start jumping up to analytic systems that take the full context of the factory into account, so that if anything goes toward a defect, then you can understand what is my root cause of that? What were the unique set of conditions? So then somebody that's selling a testing machine is not actually a tester anymore. They should rebrand and rename them, really, because it's actually a quality confirmation
system,
so that you've then got not just factory level quality, but statistically it's shown that then there is better market reliability. And that's what really matters to the manufacturers, because what happens in manufacturing, it may be painful, but you can fix it. What happens in the market, and you've upset your customers.
Right. Okay, we're running out of time, guys, so I'm going to give the last word to Jeff at the end there.
Well, this is an interesting discussion, and I've often thought that testers are kind of like driving a car blindfolded, right? When you hit the curb, then you make the correction, right? And the ideal thing is through analytics during the process to actually catch those things before they fail the product, right? So you're not finding the issue and then going back and researching it. So that's kind of the holy grail. But one last point I wanted to add is we've addressed this digital transformation from the technology side, and that is absolutely key. But one of the things that must be considered is this is not an IT project, it's not a data project, it's a culture change for the company. Right. And companies that fail to kind of promote this and generate the excitement, you can have a fantastic technology solution, but if the operators out on the floor aren't adopting it, then it's going to be unsuccessful. So think of it, my word to executives is to think of this as a cultural change and not necessarily an IT project. So
absolutely, and this debate is going to go on for a long time to come. So I think it's been a fantastic debate today, guys. It was as I expected it would be. And I want to thank you all definitely for coming in and joining us. And if you at home are interested more in this topic, then please look up our eSmart Factory Conference, which we are going to be holding in, it's on 8th of May in Nuremberg, Germany, where we'll be exploring this topic and a lot more other areas around the digitization and transformation automation journey. But for now, I want to thank my guests today for joining me, and I want to thank you for watching.
Thank you.
Thanks.
Why do something 3 times when you can do it only once? Using N1 Pass technology, BTU's new Profile Tracer is a next-generation thermal profiling tool, providing real-time data acquisition for oven optimization. It identifies inconsistencies due to temperature variables at both the product level and the heat source. Profile Tracer measures dual temperature locations as well as vibration, all in one pass, giving you time to attend the more important things in life.
Koh Young is leading a smart revolution that will change the world of electronics manufacturing. Based on our pioneering True 3D measurement-based inspection technology, we revolutionize the solder paste inspection market to such great lengths that 1 in 2 SPIs sold today is from Koh Young. Building our SPI technology, we expanded to automated optical inspection, also known as AOI. Every year, we introduce new award-winning innovations and have proudly earned the respect from thousands of customers across diverse industries. Aside from our R&D center in Korea, we have research facilities focused on artificial intelligence and deep learning across the world to help us further develop proprietary AI technologies for your challenges. With our global network of sales and service centers, we aim to respond quickly to your needs and to deliver the highest level of customer satisfaction.